check this out. You're looking at a Boeing 747 SP aircraft that's been tricked out with a 2.7 meter reflecting telescope meant to observe the universe. But it turns out it can also help us better understand molecules in Earth's upper atmosphere, which opens the door to rare climate data that we haven't had access to before. A combined mission from NASA and the German Aerospace Center, the Stratospheric Observatory for Infrared Astronomy, or SOFIA, conducts its research more than 12,000 meters high in the stratosphere. For years, this airborne observatory has been helping us better understand our universe. But it seems as though a well-planned upgrade to one of its onboard instruments has given us some important insight about our own home planet. Originally designed to detect infrared light in celestial bodies across the universe, SOFIA hosts 8 instruments on board. Each instrument is intended to study a particular phenomena over a wide range of wavelengths to provide astronomers a unique opportunity to use this suite of instruments at an altitude above literally 99% of Earth's infrared blocking atmosphere. SOFIA removes the limitations of ground-based telescopes that might result in blurry images or even incomplete data sets, as infrared light will filter through the Earth's atmosphere. And SOFIA has already discovered some pretty cool things, like the first molecule in the universe, helium hydride, and even neighboring star systems. As SOFIA gathers this data, the information collected from Earth's upper atmosphere is generally disregarded as just background noise. Over a decade ago, a German researcher proposed the idea to upgrade one of SOFIA's infrared observing instruments to better study the cosmos and the Earth's atmosphere. The German receiver for astronomy at terahertz frequency, or GREAT for short, received an upgrade to its laser system. However, the upgrade was before its time, and the researcher needed to develop the necessary tools and calibration methods to analyze the data. Now in 2021, they've been able to prove that it works. They looked at the data from a 2015 flight, which provided some much more critical information right here at home. Hidden in plain sight as background noise was the world's very first direct measurement of atomic oxygen in the Earth's upper atmosphere. And it's important to note that atomic oxygen, a single oxygen atom, is different from the oxygen molecule, O2, that we breathe on the Earth's surface, and even more different than O3 found in the ozone. Atomic oxygen is found in the Earth's mesosphere and lower thermosphere. Scientists use it to estimate temperature, and it also helps cool our upper atmosphere in 2 ways. The first is by photochemical processes, which are when the light from the sun becomes absorbed by the molecules in the mesosphere. The second is by the Earth-atmosphere energy balance cycle, and this rotation helps regulate the temperature and the climate of Earth, which is vital to maintain a livable environment for things like, well, us. So from the data collected by GREAT, scientists are hoping to create more accurate and complete climate models in the future. These will be used to predict the effects of greenhouse gases and understand the relationship between the upper and lower atmosphere. As for the future of SOFIA, it'll take to the skies once again to explore the vastness of our universe from above French Polynesia in July 2021. Scientists hope to use it to search for celestial molecules that could potentially change our view of the universe as we know it, while also studying our own atmosphere and climate. Talk about 2 birds, 1 stone. To learn more about SOFIA's previous discoveries, check out this episode about how one of its instruments found the universe's first type of molecule. Make sure to subscribe, and thanks so much for watching.